So in this video, we're going to be working a few radical halogenation predicting product examples. So we're going to predict the products of a few radical halogenation reactions. So hopefully this should refresh your memory on some of the stuff that we've gone over the past several lectures here. So first reaction is going to be ethane diatomic iodine. Even with an input of heat, iodine does not undergo radical halogenation. It does not react with alkanes. So here you get no reaction. Next one we'll take a look at is a reaction between propane and diatomic fluorine. Remember, fluorine is very, very reactive. It is also not selective. Remember, the more reactive something is, the less selective it is. So it'll react even without an input of heat, and you'll get this primary chlorination product, and you'll also get this secondary chlorination product. Remember, this is a very unselective process. So you'll get actually quite a bit of this secondary, or quite a bit of this primary chlorination product. Okay, this next reaction is a bromination reaction. We have a methyl cyclopentane reacting with Br2 with an input of heat, and so bromination, chlorination do require an input of heat to furnish the radical, whereas fluorination seems to occur without it. Remember, bromine is not all that reactive in radical halogenation of alkanes, and it is very, very selective. So the only product that you will get, the only substitution product, will be substitution at this tertiary carbon here. There is a hydrogen here not drawn in by convention. You don't draw in the hydrogens, but there are hydrogens all over here. So you have a bunch of secondary hydrogens at each of these carbons. You have primary hydrogens here and a tertiary hydrogen at this carbon. And it's at this carbon that you'll get substitution. Okay, moving on. This example is slightly more complicated. Hopefully I'll write it down correctly. Okay, so this is a chlorination reaction. Remember, chlorination, while it is somewhat selective, so tertiary hydrogens are 5 times as likely to be abstracted as primary, and secondary hydrogens are 4 times as likely to be abstracted as primary. So these are the primary hydrogens here. You have more primary hydrogens at this carbon, more at this carbon. You have secondary hydrogens here attached to this carbon, and this carbon attached to a tertiary hydrogen. Ultimately, you're going to get a mixture of products, and you're going to get quite a bit of primary substitution product because there's so many primary hydrogens, and there are actually 2 equivalent primary substitution products here. Notice that these 3 hydrogens are equivalent to one another. These 3 sets of hydrogens, I should say, really these 9 hydrogens. And these 6 hydrogens, or these 2 sets of hydrogens, are also equivalent to one another. So let's go over the tertiary substitution product first. So this one will be replaced with the chlorine. So that's one possibility. You can get a secondary substitution product, right? So let's write that in here. And you can get 2 primary substitution products. So you can get substitution at either of these carbons here. One of these hydrogens can go and be substituted with a chlorine, or at any of these 3 carbons here. And substitution at one of these 3 carbons is not equivalent to substitution at one of these 2 carbons. Because remember, these 3 carbons are not equivalent to these 2 carbons, but these 2 carbons are equivalent to one another. These 3 carbons are equivalent to one another. And the way you can reason through that is, well, these 2 carbons are attached to a tertiary carbon. But these 3 carbons, they're attached to a quaternary carbon. This carbon is only attached to carbons. Whereas this carbon that's attached to these 2 carbons is also attached to a hydrogen. Okay, let's say you get substitution at one of these 2 carbons here. So you can get something like this. Shouldn't say something like this, you'll get exactly this. So here basically one of these hydrogens was replaced with a chlorine. And alternatively, you can have substitution at one of these carbons here. We'll say it's this one. So you notice you have one of these 3 hydrogens replaced by a chlorine. Okay, so those are the four products here. That's the mixture of products. We accounted for everything. All right, let's look at one more example. So we have the same alkane as in the previous example, but in this case the halogen is bromine instead of chlorine. So how does that affect the product distribution? Remember, bromination, radical bromination is much more selective. So bromine is much more choosy in which hydrogen it's going to abstract. It's like actually it prefers tertiary hydrogens over primary hydrogens by over 2 orders of magnitude more than does chlorine. See, the ratio of the likelihood of a primary hydrogen being abstracted by chlorine, or I should say the likelihood of a tertiary hydrogen being abstracted by chlorine relative to a primary hydrogen is about 5 to 1. But the likelihood of a tertiary hydrogen being abstracted by bromine, relative to a primary hydrogen is like 1600 to 1700 to 1. So anywhere between 1600 to 1700 to 1. So quite a bit more selective. So you're really only going to get substitution at this carbon. This hydrogen is going to be replaced with a bromine. So in this case, you'll really be only getting this product here. Okay, so hopefully that jogs your memory on some of the quirks of radical halogenation in terms of reactivity of various halogens and their selectivity with regard to abstraction of the various hydrogens that can be abstracted in any given alkane.